right, in this section we're going to talk about vector representation of directed line segments. Basically, you start off with some ordered pairs. So I got 4 ordered pairs here. I'm going to plot them on my grid. 0, 2. All right, there's point A. 3, 8. Over 3, up 8. 2, 4, 6, 8. There's point B. Point C. Over 2, up 4. Point D. Over 5. 2, 3, 4, 5, up 10. 2, 4, 6, 8, 10. There's C and D. Now, if I connect those so that I have some nice line segments, let's do that. All right. So there's one line, and there's the other line. At this point, we just have line segments. We have line segment AB and line segment CD. Now, if I want to talk about these in terms of a vector or a directed line segment, when I name it, if I want to talk about AB as a line segment, I put this symbol over the top of it, and what it means is I'm talking about the line as it goes from A to B. All right? Now, I could also talk about the segment BA, and that would be the line that goes from B to A. Whichever one of these I'm talking about is important, and I have to identify that on the diagram. So I'm going to put the arrow on the B because I want to talk about directed line segment AB. And so the vector name for the directed line segment AB is 3 minus 0, which is 3. Well, let's write that. 3 minus 0, 8 minus 2. When we name a vector, notice instead of curved lines for the ordered pair, these are very pointy. They almost look like arrows. So the vector name for AB is 3, 6. It stands for the distance over 3 up 6, okay? And you find it by starting with the terminal point minus the initial point when you're finding the direction. Now, this vector has a different name. Watch how I find this one. All right? This one says I'm starting with B and I'm going to A. So A is the terminal point. So I take 0 minus 3, and I take 2 minus 8. So the vector name for that is, 0 minus 3, negative 3, negative 6. So the direction definitely has impact on what the name of the vector is. All right, positive vectors up to the right, negative from going to the left and down. All right, so let's name the vector CD. CD, how do I name that? All right, I start with D, and then I go 5 minus 2, and then I go 10 minus 4. So the vector name for that is 3, 6. If I do DC, right, that means I'm going the other way, but I do want to talk about CD, so I'm going to put my arrow on that one. But if I wanted to talk about DC, I would put the arrow on the other end. Okay, let's do DC. That means I have to start with C first, so I go 2 minus 5 and 4 minus 10. What's that vector name? Negative 3, negative 6. All right. Now, once you get the vector in vector notation, it's important because, and it's cooler than ordered pairs in that it's giving you a direction and a number of spots to count when you're finding that number. And they become really useful when we're talking physics. Now, vectors have what's called direction, and they also have magnitude. And How do you think you find the magnitude of the vector? Well, it's really the distance, and if you think about making right triangles here, and how would I find the distance of that diagonal? Well, it would be the bottom squared plus this side squared on both of them, correct? So the magnitude of a vector, let's take the vector 3, 6. So if I want, let's call 3, 6, let's call that vector u. If you want to use small letters to identify a vector, they're usually bold in the textbook. So vector is 3, 6. Its magnitude, so the magnitude of vector u, first of all, you identify it by using the symbol like this with these two bars. That means magnitude. And it equals the square root of 3 squared plus 6 squared. So, figure it out. 9 plus 36, square root 45. Of course, you have to simplify that a little bit, right? 5 times 9, so how about 3 root 5? All right. What if I wanted you to find the magnitude of a vector v that was maybe 2, 3? What would its magnitude be? Well, I'd write like this. Magnitude of v equals the square root of 2 squared plus 3 squared. That's not hard. Square root 4 plus 9, square root 13. Does that simplify? No. So that's the answer for the magnitude. All right. Now you'll be able to do some of the homework.